Other changes of the yeah, am I going first then?
Yeah. Okay, so let's start. Okay, hi everyone. My name's David. Welcome to Warwick, our user group. There's a good turnout today. Today we're going to have 4 sort of short talks, and then maybe a bit of discussion afterwards. This is also being live streamed for better or for worse. Apparently there are people watching it. I don't know if they can even hear me or see anything, but let's hope you can extend our reach a bit more. Of course, this is the first meeting of the year. Next week there's Birmingham, our user group in Birmingham. I think there's a couple of places left on that if anybody's interested. If you go on meetup.com, then you should be able to find it. Just another announcement is that there's the European R users meeting, the grand European meetup to make up for the fact that Use R is in Australia this year. So that's going to be in Budapest, and it's sort of around summer or April, something like that. So that's something, if you're interested in R and sort of meeting other R users, especially in an international setting, and that's something to be aware of. It's called eRum for short, so it's something like erum2018.org or something like that. So we're going to have 4 talks. First up is going to be Rachel, and then there's going to be a couple more. I'll be last. I might cut mine short if we're short on time. But without further ado, Rachel is going to talk about Vim mode.
Thanks. So out of curiosity, how many Vim users are there? 1, 2, 1.5? Okay, 2. Sounds good. I was just curious. So has anyone ever heard of Vim? No. So what other text editors do people like besides Vim?
Notepad++.
Okay, Notepad.
And Emacs.
Emacs. Okay.
MacVim.
MacVim.
Yeah.
Okay. So if you're Vim users, you may know quite a bit more than I do about this. If you have like tips and tricks about how to use this in R, please chime in. So Vim is something I learned when I was tethered to a Linux box, and found it useful, particularly in the context of Rstudio and with LaTeX documents. If you ever need to produce one really quickly, when it was most useful for me, I was making these maps in a LaTeX document where the file names were all the same, and so I basically just copied and pasted chunks of text and produced a very 500-page report in an hour. And it wasn't great, but it really helped me get there. So this is sort of the token comic that I think you have to have if you ever talk about Vim. Vim's just a text editor, so like you open up Notepad or text edit if you're a Mac user or whatever. And Notepad, like once you learn how to use it, you can file, edit, replace, and that's about all you can do. Its learning curve is pretty minimal. I've only used Emacs once or twice, so David can probably tell you more about that one. And VI/Vim has a pretty steep learning curve, but once you learn it, it can has really quite a lot of power and can really speed up some of the tasks that you find yourself repeating often. So Vim key bindings are preloaded into Rstudio. This is XKCD comment on the hottest editors. I'm actually behind the times. I was hoping Dudica would be here. She was going to talk about Sublime Text. I think she uses that quite a lot. CRISPR some gene editing software, and so in 2025 we'll all be editing our genomes with Vim key bindings. That'll be great. But essentially they're just text shortcuts that enable you to work solely from the keyboard instead of constantly using the mouse. So what are they? An elaborate set of keyboard shortcuts that have been around for about 40 years, I think. So you can think of this as a way to program your text. And so if you have a big text document, then instead of highlighting and copying and pasting, you can do all of that from effectively a command line at the bottom of your document. Vim on its own is just something that comes pre-installed on most computers, and along with Emacs and sort of the other common text editors that you find. If you use it just on its own, it can also be used for version control because it automatically saves files of what the last version of your document looks like, and then you can back it up should you accidentally widen it, which I've done. It can also be used as a file management system. It can also be used as a Windows. It can split your windows. in RStudio, you can actually, there's a setting where you can have 4 different cursors, and so you can be typing on 4 lines of text at the same time. And most conveniently for all of us R users, it's an option in your RStudio preferences. So all you have to do is just go to global options and click preferences, and then you have those just in any, as you work in RStudio. So what do they let you do? You can quickly search and replace in a file from the command line. So without hitting Control F and highlighting and picking the right selection and all of that, you never have to leave the keyboard. And so if you're really in a, if you ever have one of those coding rampages and you're in a really sustained train of thought, then it's really nice to not have to pick up the mouse. It sounds like a silly thing, but I found if you really are on a roll, it can save you some time. You can copy and paste just by using a few characters on the keyboard. So if you want to copy and paste a line, then from your command line, you would just type YY for yank and then P for paste, and it just spits it out without needing to highlight anything. So that's an example of a Vim command. It operates as kind of like a language for text, and so there's different verbs, and all of these are sort of handily installed on a cheat sheet in RStudio that we'll take a look at. You can also scroll from the keyboard, so instead of tabbing up and down through your document and going over to the mouse, you can just do it very quickly with Vim shortcuts. And another thing that's handy is adding marks to hold your place. And so if you have a long, very long R file, then you can set these little marks that are invisible, but then you can search and automatically go to those lines without needing to scroll or Control F and flip through. You know, if you, I don't know, sometimes I find that like I'm remembering that I'm on the 36th instance of, you know, DF in a document or whatever, but you can do that much more efficiently with Vim. That's what they are. How do you use them? Vim, what makes Vim odd and why it has a steep learning curve, part of that is that it has different modes, and it doesn't really have a user interface. It's just like your RStudio console looks just the same, but it has these different modes that you can operate in, and the ones, so visual is just, the 3 modes are visual, insert, and normal. And so visual is just what it sounds like. You can see your text, you can move around in it. What you can't do is edit it. And so I think where people sort of crash and burn when they start to use Vim is they open it up, they try to highlight or copy and paste something like you normally would. And because it's in visual mode, then it just cuts out. So the trick is to do things in insert mode, which you just get in by typing I. And then normal mode just lets you move around with the keyboard. Again, there will be a shortcut featured, a cheat sheet featured solely that has all of these commands. And so to get in and out of the modes, you just type the corresponding character on the keyboard, and you press escape to exit any of the modes. So the point being that this lets you alter your text from the command line without needing to waste those precious seconds to get to the mouse. Why should you bother? Because you can't, all of us at some point wind up working in the terminal, so you might as well check it out with as many neat tips and tricks as you can. I think it's particularly powerful with tech, where I often find myself copying and pasting big chunks of code and wanting to find fast, efficient ways to search and replace. And if you can touch type, it helps maintain focus. So that's why you should bother with Vim. How do you set it up? Vim comes pre-installed on all these systems, and if you're on Mac, you can install it using Homebrew because the version that it comes preloaded with is kind of outdated. For the rest of us, then you just use it in RStudio. So if I pull up RStudio, I'm going to go to Tools, Global Options, Code, and the key bindings on offer are default Vim and Emacs. So if I select the Vim ones and apply it,
You selected the Emacs ones.
I did great. so now if I'm in my editor, then so now if I want to instead, okay, as an example of a dumb but effective copy and paste. Oh, sorry, actually, before I do that, so when you're in Rstudio, if you don't see the cursor with the box, then you're just editing it normally. And if you press escape, then all of a sudden you're in this sort of neutral territory in Vim where then you can pick what mode you want to enter. And so, and then, so now I can work from the command line because I have this box that's showing up. Does that make sense? So now when I start typing on the keyboard, you'll notice that it's what I'm typing is actually popping up at the bottom of my window. So you see the semicolon. Sorry, not semicolon, it's just the colon. So the colon is how a lot of Vim commands start. And what the nice people at Rstudio have done is if you type colon help, then that brings up the cheat sheet with all of the shortcuts. And so this will tell you everything that's been copied over into Rstudio. And so motions on the keyboard, you use this H, J, K, and L. Those are so it's going to take you left, down, up, and right, respectively. I won't read all of this to you, just sort of call out the ones that I think are easy if you're going to get started with this. One I use a lot is GG for go to line. So GG24 takes me to line 24. I use yank a lot. So yank, two Y's to send something to the clipboard and just a P to paste. And so you can also tell it how many lines you want it to copy. So if you have a nice little code chunk that's making a plot and you want to make the same plot but alter a little bit, and it's 4 lines of code, then you would say 4 YY and then paste it. And so let's see. There's also some ways to get to the front of a line really quickly, ways to get to the end of a line, ways to start new lines before or behind your cursor. Those are the ones I'll point out. Any other, from any Vim users, like any other particularly useful ones you find to people who are just starting out with this? They're here. Type colon help and they'll pop up. Actually, my other favorite one is search. And so okay. So if I was going to copy and paste this line, then I would type YY, which you can't see, but you'll have to take it on faith that I did. And then hit paste. And now I have 2 irises. And so now I'm moving over using L to get that way. And then if I want to instead just look at the summary of that one, then I've copied and pasted it from the keyboard. And then supposing I wanted to do a find and replace, I want to do the same thing, but instead I want to look at the simple, the pedal links, then, so you can see I'm typing in the bottom of the script window now. So it's colon %S simple. That's what I want it to find, and I want it to replace it with pedal. And I typed \G because I want it to do it everywhere for some reason. And then it's automatically edited in the text.
Does the YY cover your whole line?
Yeah, YY's for 1 line. If I wanted to now copy 2 of these lines and then change it again, then I would go 2 YY, move down, and paste 2 lines at a time. And
So
then
the previous 2 lines from your cursor.
the following 2 lines from the
Okay.
cursor. Yeah, it's always going down unless, it reads top down. So that's not the wildly effective demo, but how a basic demo of how these commands work in R. So I would just encourage you to flip the global options on your Rstudio and play around with it, at least read through the commands and try it out for a little bit. So it really can save you some time. And then the last 2 slides I had were just Vim extras I found in the preparation of this talk. I realized there's tons of plugins. So does anyone use Atom or any of those other? Okay, so sort of similarly to that, people have made a lot of different plugins to Vim that can speed you up and save you some time. Those are in bundle, and MacVim, which I haven't used, but I think someone back who's used that. So it gives you a nice interface on Vim and Mac. And then there's just the last slide I have is just resources. The Coming Home to Vim is this very poetic blog post about love of Vim. And yeah, learning Vim is sort of an intro into a longer intro into why you should use it. But really for our purposes, I think just taking a look at that cheat sheet in R is a good way to get started. That's what I got. Questions now or later?
Does anyone have any immediate questions now? No, we can discuss it sort of later or in person. So can we move on to the next one, Lewis? Do you want to go next?
Oh, sorry.
Sorry, I wasn't thoroughly right.
Okay, so now Lewis Rendell is going to talk to us about object-oriented programming using S3. Lewis has been volunteered for this talk without his knowledge. So
I'm aware now.
Yeah, he's aware now.
Yes. Okay, so my name is Lewis Rendell. I'm a PhD student here in statistics at Warwick, and the talk I'm giving today is on this idea of S3 classes. I'm going to try and introduce them to you in a fairly non-technical way. For this talk, I've basically put all of the content I'm about to discuss in this Markdown file, which I'm going to give to David to go onto the resources page on the website. So all the information should be here, including all of the technical bits about how to set it up. But I'm going to present it to you as a demo because it seems a bit easier. So the way that I discovered S3 classes and this whole idea was the question that I asked myself was, why is it that certain functions in R, depending on which object you give them as an argument, they tend to produce different looking output? And I couldn't really work out why this was, so I looked into it. To give you an example, the function I'm going to look at is the summary function, which Rachel just used just now, and I'm going to show you some of the different outputs it can sometimes appear to produce. So if I just generate a numeric vector, so I'll just call it values, so it's just 20 observations from a standard normal random variable in a vector. If I apply summary to this vector, then we get a nice printed out list of some of the key summary statistics of that vector. So minimum, maximum, quantiles, median, and mean. So applying summary to that vector gives me that. What about if I apply summary to something slightly different? So if I look at the iris data set, just to remind you, the top of the data set looks a bit like this. It's a data frame, so it's got 5 columns, each containing some data about some irises measured a long time ago. If I apply summary to this object, then I get something like this. So again, I get something printed out to the console. And again, it's kind of lists of summary statistics, but now I've got the summary statistics for each column in my data frame. So the output looks slightly different again. It's quite a useful function, this, but lots of different forms of the output. Now what happens if I look at a linear model, for example? So if I use the lm function to just regress the sepal length on the sepal width for this data set, store it in an object called iris model, what happens if I call summary on that? I get something like this. So again, it's something printed out to the console, but this one has got some information about the specification of the model, the residuals, the coefficients. And so seemingly, every time I call summary on different objects, I'm getting different output. And so you might wonder what on earth's going on here, what's actually happening behind the scenes. And to work out what's happening, we can look at the definition of the summary function, which gives us a bit of a clue. So if I just type in summary to bring up the definition, you'll see that in the definition, there's this call to a function called use method. And that's kind of the underlying architecture of what's going on here. So to explain some of the key terms I'm going to use, summary is what's known as a generic function. So it's effectively just an interface to various other functions. Depending on the class of the object which you pass to the summary, this use method function will look at the class of that object and run a different function from one of several which have been defined. And those different functions are called methods. So a method is effectively a definition of this function to be used with objects of a particular class. Perhaps to explain this a bit better, if I show you some examples based on what I've just showed you. So in this case, all of these three objects seem to produce different output when we apply summary to them. The reason is they're all different classes. And the way to find the class of an object is to use the class function, believe it or not. So if we look at our vector of numeric values, which we have first, we call that values. If we look at the class of that, that's numeric. The class of our iris data frame, perhaps unsurprisingly data frame. And if we look at our linear model object, which we created at the end there, that has class LM. So each of these objects has a different class, which is stored as the attribute of the object. This is perhaps a good point to say that in general, objects can have multiple classes. And if that's the case, then when you apply class to that object, you'll get a character vector containing all of the classes to which it belongs. So each of these objects have different classes. The way that our generic function, our summary function, works is that when we call it, the use method function within it looks at the class of the object and calls a different method depending on the class of that object. And the way to see all of the possible methods available for some generic function is to use the methods function. So if we apply methods to our generic function summary, there we go, we get a really long vector which looks like this. And this details all of the possible methods available for that generic function. Now, methods for a generic function, they normally conform to this naming convention, which is the name of the generic function, then a full stop, and then the name of the class to which it applies. So all of these are just functions, but they follow this particular naming convention, which allows them to be implemented as methods. The one exception is summary.default, which is this one here, and that's just the default method. So what happens is when you call summary applied to an object, it looks at the class of that object. If it can find a method for that particular class, it will do that. But if it can't find one, then it will revert to the sum default method. So all of these are just functions which are to be run given that particular class. So that's the way of finding them all. Perhaps, again, this is a good time to say that this is a specific implementation of this kind of system within R. So this is known as S3, is the name of the whole system. So specifically, you can refer to S3 classes, S3 methods, S3 generic functions. There are other systems available, which I'm going to mention at the end, but this is by far the easiest way of doing it. So essentially, this is what's going on. This is why we're seeing different output. So when we called summary applied to our linear model object earlier, this iris model, it has class LM. So when we run summary, the method that gets executed in practice is this one here, summary.lm. In the case of when we ran summary.values, values was a numeric object. And if you look down the list, there isn't actually a method defined for objects in numeric class. So in that case, it reverts to the default method. And that's what's actually being run. And because each of these methods are differently defined, we have different outputs in each case. So that's what's going on. I'm going to give a very brief example, a very simplistic example of how you might use classes and define your own generic functions and methods in your own work. So the example I have, it's a very fictitious example. Suppose you're running a shop and you want to encode information about some of your employees and some of your customers. And one way you could do this is to encode information about each person as an R object. And then within that R object, you can store information about them in various fields. So you could do this with a list, for example. So to show the first example, suppose my first employee is called Jane Smith. She's a manager. Salary is £40,000. We could save her or save her information in an object which looks a bit like this. So it's just a list. And each of the fields, or each of the elements is a different field storing some data about that employee. So that object kind of contains all of the data within it. I've called it emp1 because she's the first employee, but you could call it anything. So all it is a list containing various fields. And to assign a class to this object, so it's called emp1. I'll just run that. If we want to assign a class to it, all we need to do is write class of emp1 and then assign it the class we want. Because this type of object refers to an employee, we'll call it employee, because that seems to make sense. So now, if I look at the object I just produced, if I call it emp1 and see what we've printed out, it's just a list with all those different elements as fields containing data. But notice at the bottom there, we've added this class attribute to it. So in a sense, it starts off as just a list, but we've given it this particular class to look at. And in fact, we can check, just in case we weren't sure, this object is now an object of class employee. If we had another employee, we could do exactly the same thing. Create a list in exactly the same way. So here, Tim Jones, the shop assistant, we've stored data about him in another object, and we can assign that object the same class. The idea being that objects of the same class have similar structure, and therefore we're going to work with them in similar ways later on. So we've created two employees, objects of the same structure. Suppose maybe we want to store data about one of our customers as well, or our customers. If we're going to store information about customers in an object like this, it's going to have a slightly different structure because a customer isn't going to have a role or a salary in this case, but we might want to store some different information such as the total amount they've ever spent. So let's say Margaret Martin is one of our customers. We want to store data about her in a slightly different looking list. It's a slightly different structure. We'll call the object cust1, which is the first customer that we've encoded. But we're going to assign this object a different class to reflect the fact that it has a different structure, and we're going to work with it slightly differently. We'll assign the class of this to customer. Seems to make sense. So again, if I just call the object, nope, that's what it's called. We can see there we've assigned customer as the class attribute. What can we do with these? Again, this is a fairly simplistic example, but suppose we want to code some function such that we give it an object representing a person, and then it prints out a message welcoming them in some way. So if we give it an object representing an employee, we want a message saying, welcome back to work. If we give it an object representing a customer, we want it to say, welcome to our shop, or something of that nature. We can do this using S3 generic functions and S3 methods. So we can define a generic function, which we could call welcome, for example. And then depending on what type of object we pass it, as in which class that has, it will call a different method, which will produce different output. So to show you very briefly what this looks like, it could look a bit like this. So our generic function, we just call it welcome. And this includes this use method line, which we saw within summary. So that kind of declares it to be generic in a sense. And that kind of triggers the right method to be called. And then to define our two methods, we effectively just define normal functions, but we use this particular naming convention. So as before, it's the name of the generic function, then a full stop, and then the name of the class to which we want that method to apply. So don't worry if the code doesn't make sense, but all it's doing is either printing out a message saying welcome back to work, if it receives an object of class employee, or printing a message saying welcome to our shop, if it receives an object of class customer. So if I just execute these, and just to test it works, if you remember, emp1 was our first employee, so that's an object of class employee. If I now apply welcome to that, welcome just being the generic function, we should get a message saying welcome back to work for that person. If we apply the same generic function to an object of class customer, then we get the other message. So all it's doing is it's calling the appropriate method for the class of objects involved. So there are all sorts of applications for this. The nice thing is that effectively we define two different functions, but we're accessing them through a common name, if you like, which can be good for usability, so that the eventual user of whatever code you're writing doesn't have to learn the names of 30 different functions. They can just learn one and then the appropriate method will be called. So this is one implementation of this kind of system in R. Just to explain, there are several others available. So this is a fairly basic implementation of this whole idea of object-oriented programming. The idea being that it's programming in such a way that your data are stored in objects containing various fields of data, and you manipulate those using procedures known as methods. And each of your objects belongs to a particular class, which determines its structure within it and so on. S3, what I've shown you today, is perhaps the simplest and most informal way of doing this within R, but it's used in most base R packages. So summary, like I showed you earlier, that's an S3 generic function. Plot is similar, print, and you can define your own methods for these depending on what you want to be produced when you call plot or summary on your object. So it can be quite nice. One possible disadvantage with using S3 is the informality of it, and it's not very rigorous. So if you notice, the only thing I needed to do to tell R what class an object is to change the class attribute. So an object having a particular class doesn't give you any guarantees about the structure that's within it, or particularly for S3 classes. There's no guarantee that an object of a particular class has a particular structure, which could cause you problems when you're writing methods for that object, because you don't necessarily know that objects that you pass to it are definitely going to have that structure. S4 classes are another way of doing this type of thing within R, and they have a bit more rigidity, they're a bit more formalized, and they have ways of validating that objects conform to a particular structure if they have a particular class. But they have a slightly odd syntax, so they can take a bit of getting used to. If you're familiar with the matrix package, I think that uses it quite extensively, so that might be one way of looking at it. If you've ever used other languages, particularly Python is the one I'm aware of, they approach the whole idea of classes in a very different way, in a more traditional way when it comes to object-oriented programming, where methods are not associated with functions, but with objects. And calling functions associated with objects alter those objects in place. So rather than creating a copy, they kind of alter the object on which they're applied. You could do something a bit similar to that using something called reference classes in R. They try to emulate that kind of idea. And R6 classes are kind of a more recent version of those still, which are a bit more, they're supposed to be kind of better performance, a bit more self-contained. So if you're familiar with that type of structure, those two might be for you. In general, I would say S3 is sufficient for most purposes, particularly if you want to integrate with existing generic functions in R, such as print, plot, and summary. But there are some details about how you might choose which one you want, and some more details about those in the Markdown document, which I showed you at the very beginning. Here it is, which should be on the R user group page for you to look at, and that contains all the code from this talk, should you want to go through it. I think I'll leave it there. Thank you.
Right. Does anyone have any questions for Lewis?
Yep.
Joe?
So I was wondering, have you actually used the S3 classes yourself for a serious coding thing, and what was it?
I use them quite a lot. So my background, my research at the moment is in kind of Monte Carlo methodology. Don't worry if that doesn't mean anything to you. But one thing I quite often have to do, if you think of Monte Carlo, you have this kind of burn-in idea, so which is effectively taking a vector and deleting the first however many elements of it. So I've used it, I've got a kind of generic function which does that, which has a default method, which is just deleting the first however many elements of the vector. But because of the work I do, sometimes instead of having a vector, I'll have a list containing several vectors, or I'll have some list structure containing lots of different vectors because of some kind of distributed algorithm which does it all in parallel and it's also in a list. So by defining some generic function, kind of regardless of the structure which I give it, as long as I have defined a particular method of that structure, I can just use that generic function and it will use the appropriate method to kind of burn in the sample appropriately. So they have their uses. Essentially, if you've got lots of functions which do something very similar, but depend on the structure of the object you're giving them, this can be a nice way of kind of bringing them all together so you don't have to find that specific function each time. But, so they have come in useful for me.
So just so if I was approaching that problem, the way I'd probably do it would be with a function with a series of different if statements.
You could do. You could do.
Is there an advantage that you know of doing it with the S3 approach as opposed to if statements within your function?
So would that be if statements to check the class of an object?
It's essentially the same thing.
It's effectively the same thing. I suppose the benefit of doing it this way is that each of your methods is a separate function, rather than having one function, really long function with lots of if statements, which maybe is a bit harder to debug. yeah, I think this is just kind of a nice inbuilt way of doing exactly that. So it's just nice infrastructure. But yeah.
Okay. Any other questions?
Yeah, one.
Yeah.
There was some list of summary functions. You had summary dot.
Yep.
Some had a star next to them. Does that mean it's kind of matching the wildcard pattern at the end, or?
I think that is, I think it's just hidden functions of some sort. If I just try it here. I don't believe it's a wildcard, but I will just check. So if I just check methods, I think it's just indicating functions which are somehow hidden to the user.
I think you're right, Louise.
I think it's something like that, yeah. They're invisible functions or somehow, so you can't access them by name.
Okay.
Beyond that, I wouldn't know.
Yeah, so if you pass a class of that type, it might be able to execute if you couldn't type in with the command line and do something.
Yes, yeah, I think you would be able to do it that way. Yeah, I think that's what it is.
Okay. Let's thank Luce again. So next we're going to have Kenneth Lim. I don't actually know what he's going to talk about. It was based on the blog post, but it might be about making blog posts itself.
Thanks, David. So I'm going to speak about my blog, which I created using R. Show you what it's about, get some feedback from you, and point you to some resources that I used personally to start the blog. So I won't take up too much time. So let me just time myself so that David doesn't rush on. Okay, so I recently created a blog that presents data about Singapore, which is my home country. And it's aimed at a non-technical audience, which means I hope it would get through to people who have just a very vague interest in anything to do with statistics. So it might not necessarily be university students. It might be the general public who would be interested in things that are happening in Singapore. And what I try to do is I try to take data that's publicly available online, usually uploaded by the government or some government agency, and I try to turn them into simple plots and provide very short explanations so that people can read them and kind of get a feel of what's going on. So I'll give you an example. So my first post, which was about 1.5 months ago, talked about the changing number of citizens, permanent residents, and non-residents in Singapore. So I asked the questions: how many people are there in my country? How many are citizens, permanent residents, and non-residents? And how have these numbers changed over the years? And this is a hot topic in Singapore. And so I take the data that's provided here, singstat.gov.sg, which is really an Excel sheet with lots of sheets, and one particular one has a row, several rows about the population in Singapore. And here we see that starting from 1960 to 2017, the population has grown quite a lot. And the blue colors represent changes in definition of what the total population was from that year onwards. So in 1960, for example, we had just about 1.7 million people as the total population. And in 2017, we reached, was it 5.61 million people, right? And similarly, we can look at this kind of plot where I break them down by residence type, and you can see trend. Also, I think this might be more interesting, the percentage of the total population by residency, and the red being Singapore citizens, the blue being non-residents, and the green being permanent residents. And you can see over time, especially from 1990 onwards, that the number of Singapore citizens of the total population starting to go down, whereas the non-residents are starting to go up. And yeah, so I try to do something like that. And the latest one, there's also there are more males or females in Singapore. And the latest one talks about whether Singapore has the highest car prices in the world. And here, I say, it's apparently Singapore is ranked as the most expensive place in the world to own a car according to the EIU. So currently buying a new Toyota Corolla would cost about $75,000 US. And why is that? It's because in Singapore, before you buy a car, you have to buy this thing called the Certificate of Entitlement, which is the right to own a car for 10 years. Right, and once this certificate expires after 10 years, you either have to renew it and buy a new certificate at whatever the price it is now, or to what we call scrap your car, which means to send it to the yard and say goodbye to it, right? So essentially, it's like a 10-year lease on a car. And how much do these, for short form COEs, the certificate of entitlement, cost? Well, we can see over time from January 2010, where the data is available, to 2017 in July. These are the prices on the y-axis, and on the x-axis is the dates. And the dates meaning, and they're colored by bidding rounds. So there are 2 bidding rounds each month where you can bid for a COE, right? And the amount that's being bid through some formula would be the amount that you have to pay for the certificate of entitlement. And you can see that for the different categories of cars, they have reached, some peaks of 90,000 here in 2013, slightly over 95,000 for category B cars, slightly bigger, and in category E, we have close to 100,000 Singapore dollars just for the COE, which will expire in 10 years. And similarly, we have this thing called the COE quota system, which means each time you bid, how many COEs are available, right? So it's a limited amount, and why we have this limited amount is apparently we want to try to restrict the number of cars on the roads, okay? And I think an interesting pattern, so we can see this, the number of COEs available over time for the different car categories. And I think an interesting pattern, which I did not expect to see, was here. And I talked about it, saying that there's an interesting pattern in category C, which is for the goods, vehicle, and bus vehicles. And there's a jump, there tends to be a jump from April to May. So here, to here, and then from May to July, it stays constant. Sorry, April to May, yeah. And then it stays constant till July, and then it falls, right? From 2000, and this is 2014. Something similar happens again in 2015. And I think that this was really kind of striking for me, this big spike here. So it's a fun way for me to get to understand my own country and get to play around with data and think about, if I were to present it, how should I present it? And this is something that's always on my mind, because I didn't come from a statistical background, and it's only 2 years, 2.5 years into my PhD training that I am quite comfortable with reading plots, with looking at things and seeing some patterns in there. And so this is always on my mind when I'm making plots. How do I convey my message simply? And that's where I hope some of you who might have experience could share what you find particularly useful, or you can critique my blog posts. I'm always looking to improve. And also, so my blog, in case you did not know, is numbers.sg. Okay, it's quite simple, numbers.info. And the resources that I used to get the blog up and running, really, I think this is to me one of the most useful resources online. It's written by this person, Ellison, and it's written, I would say, for a non-technical audience, for someone who wants to start a blog in R, using R, but doesn't know how to. So she talks you through very simply in 8 steps what to do. It's quite straightforward. So it requires some knowledge of GitHub. I never used GitHub before. It took me a month to learn GitHub. So if you're more savvy than me, then this should be a breeze. But if you are not so savvy like me, I would recommend reading here. Sorry, Happy Git with R. here. So just to get yourself familiar with the phrases like push, pull, commit, and things like that. I found it very useful. So yeah, read this post. It also, I used the Blockdown package in R, so this is the official kind of documentation that you can read. That's also useful. Personally, I found it a bit difficult because I'm not very savvy, but that's fine. Alison wrote a great post, so that really helped me. And yeah, so I would like to stop there. Thank you very much.
Yeah, so has anyone got any questions for Kenneth? I mean, appreciate you'll be able to look at his blog sort of in your own time and stuff. And we'll make these links available on the website.
It's here. Great.
Okay. If not, we've got about 10 minutes left, so I will quickly try and present my own little mini talk. Some of you might have seen, I did a blog post recently. It was about getting R running on Android on your smartphone. So if I've not got enough time to sort of get it projected onto the screen, then I can at least point you in the direction of the blog post that I've done about it. So, right. So, okay, well, it's supposed to, there's this incredible app that allows you to connect to like sort of different laptops and stuff here, but it doesn't seem to work. So instead, I'll just revert to my backup, and then I can always show people sort of in person later on. Right. So, okay. So basically, the way that this works. So this is my website, selbydavid.com. There's an app called GNU Root Debian, and what it does is it basically emulates an entire Linux installation on any Android device. And to some extent, so I don't really know how it works. Some of you might know that Android is sort of based on a similar sort of base to Linux, although it's not actually Linux. It differs in a lot of ways. So I think it sort of takes advantage of some sort of underlying systems within the Android system, rather than just, like dual booting an entire new operating system. But the cool thing about this is that you can just install this application. So it's GNU Root Debian. Debian is just a Linux distribution, and you can just you open it up, and you pretty much straight away get a. So this is a terminal in Linux, or what looks like Linux. And so if you're used to sort of working with the command line, if you've used Linux before, then it becomes very straightforward. The only thing you might notice is that there's a hash here. Normally there's a $, so that means you're already a super root user. So if you're used to writing things like sudo apt-get or whatever, instead you only need to write apt-get. So I've got a full guide on my blog, but basically what you do is you start off with a blank screen, and to install R, you enter a few different commands. So first you need to update sort of your distribution, and then you type in some commands. There's a package repository that includes R in it, and so you install rbase. And what rbase dev does is it allows you to install packages from source. So if you're installing extra R packages, some of them aren't available as binaries, and so it will install them from source. So if you just run this command, it'll install both of these packages, and you'll end up being able to type the letter R into your terminal. So if you've got R on your computer and you've got it set up on your path on a regular computer, then it works exactly the same way on Android. So you just enter R and it launches R. Now you're using R, and so you can type in any sort of commands that you want. and if you want to quit, so one of the problems that people have faced with Vim and to a certain extent with other programs is, well, how do I get out of R once I'm in it if I want to run some other programs? So you run Q open bracket close bracket, because you don't have the option of just clicking the X in the top corner. So you can also run some little one-liners without having to open a whole R session. And to a certain extent, this is just sort of a mini tutorial on how to run R from the command line, so I won't go into too much detail. But one sort of hot tip that you can use is, because you need to sort of jump around your code and go up and down and that sort of thing, on most touchscreen keyboards, you don't have up and down keys, and in this terminal you can't just touch on something and go up a line. So if you want to repeat the previous line and edit it, normally in Rstudio or what have you, you hit up. You can install a keyboard called Hacker's Keyboard, and what it does is it gives you a massive QWERTY keyboard with all the keys on it, and everything is tiny and almost impossible to touch, but it means that you get arrow keys, so you can jump up and down, and if you're using a tablet, then it's much easier. Or alternatively, you can plug in a Bluetooth keyboard or something like that. This is one option. I don't really like using this keyboard for normal typing because the keys are too small and it doesn't have like sort of swipe typing and all that sort of thing. But it's easy enough to switch between keyboards. Just hit this button on your hotbar. So I'm just going to sort of skip ahead a little bit to there's a few sort of examples. So one thing that you can do is you can navigate around on your system. I'll sort of leave it as an exercise just to read these details so that we don't just have to sort of read through these command line things. But you can navigate around your Android system, and the cool thing is that it's not self-contained, so you can access all the files that you otherwise have on your Android phone or on your Android tablet or what have you. And what this means is that you can use a normal text editor to write a script. So maybe I've written this script, and what it does is just uses a very basic base R. It just it makes some funky plots. If you use a text editor, you can write this with a nice interface. You don't have to do it within GNU Debian. You can copy it from, you can download it from somewhere, or you can type it on your phone, and then you can save it in, for example, your Android documents folder or Rstudio or something like that. You can find your way there using the command line. And then you can run the script. And so I made this plot on my phone using R. It's not a data-based plot, but I just wanted something that looked nice. The other interesting thing is that because you've got a text editor and because you can install packages, you can install knitr and R Markdown, and then you can write documents and blog posts, and then you can render them on your phone. And then you can install things beyond just R on your phone. You can install Git as well. So then actually you can end up using your phone to do absolutely everything ever, as long as you've got good eyesight and sort of small fingers. So for example, you might write a short post like this, and then from the command line, you just use a sort of a mini sort of one-liner. So it uses R script command. And then E just means sort of run a one-liner rather than a file. And then if you, so you might be used to clicking the knit button in Rstudio using a hotkey, but if you wanted to do it the command line way, then this is the R command to use. You use the R Markdown package, you run render, and then you find the text file, and you need to navigate somewhere where you can find this text, this RMD file. And then what will happen is it will generate, so by default usually it's an HTML file in the same folder. You can check that it's there, and then you can open it in your normal Android web browser. So the only thing that you need to use to that isn't just a normal Android application is just when you're running scripts one by one. So so you can have an entire script written into a text file, and then you can R script, the name of the text file. Or if you've got some patience, then you can sort of write one-liners, or you can work interactively. Because I couldn't get the projection to work, I've just got a sort of a little, here's one I made earlier, sort of GIF. So there we go. I've opened up R. I've want the first few rows of the iris data set. This will be used the keyboards. I want some random normal numbers, and then that's it. And then I'm just sort of looping around again. This program GNU Debian has been around for a while, but I have not really seen many people use it for R, or at least sort of comprehensively, how you can use it with other tools to sort of get almost anything done. The only caveats are you can't have the very, very latest version of R. The best you can get is 3.3.3, which is sort of like one major version behind. So but that's enough to install most major packages. Maybe not like the most bleeding edge ones that insist that you have the very latest version of R, but it's enough to get like almost any work done. And realistically, you're not going to be writing huge long scripts on with this. But if you want to write a quick post, or I just want to check what's the iris data set look like again, I need to remind myself it's very important that I do so. Like while on the bus. Then you can do this, and the advantage is, unlike some other things where they say, oh, you can SSH into someone else's computer, or you can run an Rstudio server or something like that. This, other than when you first install it, you don't need any connection to the internet. So I live up in the deepest, darkest depths of Yorkshire, and I don't really like to take my laptop with me over Christmas. So it allowed me to write this blog post over Christmas just on my phone, and then eventually I can get someone's computer. I can check that it works, but I don't need to have R installed on every computer I ever use. I can write a document in a normal text editor, and then I can just sort of render it on my phone and carry it around with me, and share it, tweet it to someone, send it on WhatsApp or what have you. So that's all I've got to say really. Thanks very much. Does anyone have any questions about that?
What do the plots look like?
Well, when you run a plot,
Yeah.
so there's no graphics device. So what you have to do is you have to do it the old school way, where you open a graphics device, run the code, and then close the graphics device again. So you have to say, I want to make a PDF from the command line. Apparently you can. So I did accidentally go into the graphical user interface of Linux. And so you zoom out and you have all these windows and you have a desktop and everything. I don't know how I got there, but you can do it technically. So you could presumably have like an X window or something like that, depending on exactly how the Linux distribution works. But I don't know how to do that reliably. There's sort of options and stuff in the app, but I'm not experienced enough of a Linux user to know sort of, if you were stuck within a full screen terminal, how you would go out into X windows or something. Some other people here probably might know a bit more about that. So what I've been doing is just doing it via R Markdown documents and just manually saying, I want to make a PDF file, writing out the code and then turning it off, and then it saves it. And then you just open it in your PDF reader or your web browser. So yeah, that's it. David?
I think you've convinced me I need a bigger phone. I've just got one trivial correction. That Linux distribution is called Debian.
Debian, okay.
Named after Deborah and Ian.
Ah,
Who invented it.
there you go. You learn something new every day. Brilliant, thanks. Okay, so that's pretty much all we've got time for. I think some people might be wanting to come into this room. So we're going to end it there, but if you have any questions for anyone, then feel free to talk in person. And thanks very much for coming.